In this tutorial, we will explain the manual use of Ergo360 and the individual tab functions along the bottom menu. First, let's open Ergo360 and notice the username and password are filled in and both green tabs below are selected. Before we log in, since we want to demonstrate the manual function of the app, we will deselect the ADS Oxygen ETP tab. This will allow the app to open without any information being filled in from the flight plan and allow the user to make manual entries. The initial process entry box is synonymous with the Start Ergo tab found in the lower left-hand corner. First, let's open the oxygen units window and select which metric is being used for the type aircraft being flown. The app will allow the user to select liters, PSI, or percentage of full. The next window will display which aircraft will be used for this flight. Once the aircraft is known to Ergo360, it will reference a fuel and oxygen database specifically for that aircraft. When the aircraft is selected, it will autofill the maximum values for the next 3 windows. Any manual input will be a number less than what is currently being shown. The last 2 windows are the diversion airports with the longest ETP analyzed on the flight plan. In this example, we'll be using Gander, Newfoundland and Shannon, Ireland. Now we'll click Submit to advance to the plan mode. In the plan mode, all of this data, with the exception of the oxygen quantity, can be found in the ETP analysis of the flight plan. The first entry box, ETP altitude, is the depressurized altitude found on the flight plan. The ETP time is the time from the ETP to the diversion airport. Remember to use the longest time of all ETPs provided. ETP fuel is the fuel remaining at the ETP. It is the fuel needed to fly to the diversion airport. Oxygen PSI is the dispatch quantity planned on departure. Now, in the last entry window, the latitude is automatically calculated based on a great circle route between diversion airports. Should the actual route not fly over the diversion airport shown here, then inserting the latitude from the longest ETP on the flight plan will displace the planned aircraft position visually to reflect a more accurate solution for the pilot. So in this example, let's go back to the plan mode and we'll move the latitude several degrees north. Here you can see the aircraft moves north, and with it, it drags the center of the circles, reflecting a more accurate solution for the pilot. Actual mode. Selecting actual mode allows the pilot to enter real-time data, and it will display actual fuel and oxygen reserves around current aircraft position. For convenience, a copy from the plan mode tab is available, and it will enter data already provided from the plan mode. As you can see, the aircraft altitude from the flight plan is entered but can manually be changed. No wind direction or velocity has been entered, but can be at any time. Entering the wind direction and velocity will skew the distance circles to provide a more realistic effect that wind will have on fuel and oxygen distances. The pilot can visually see the effects of wind on fuel and oxygen reserves. Fuel on board at the ETP is also copied from the plan mode. Fuel flow and true airspeed come from the ADS database using long-range cruise data one should expect to see based on altitude and aircraft weight. This data can be manually entered at any time in flight. Oxygen quantity, as read on the flight deck instrumentation, can be entered or updated here. The latitude and longitude should automatically be entered from the iPad GPS with no input from the user. Should a manual entry be necessary, the pilot can update the latitude and longitude at any time manually from another source using data from the FMS as an example. Once the iPad GPS position is restored, it will automatically begin updating the aircraft position, and this can be reflected by observing changing latitude and longitude by its own. Once finished, click Submit on the app, and it will skew back to its present position, in this instance, Teterboro. The 100% fire tab will display the projected oxygen distance available based on the pilots using the crew oxygen mask in the 100% position. This is normally used to fight a fire but can be used any time deemed necessary by the pilot. The 100% mode has a higher than normal flow rate and can easily impact oxygen reserves. Touching this tab opens an entry window, and the user needs to enter the cabin altitude and the number of crew masks in the 100% mode. No numerical distance is provided until the user opens the aircraft icon and displays the white information banner with this data displayed. In this instance, two pilots can fly for 765 nautical miles at an altitude of 15,000 feet. Airport tabs. Clicking on this tab will display airports as colored pushpins. Airports are color-coded based on the length of the longest runway for that airport. Green airport icons have a runway length greater than 6,000 feet, while red airport icons represent runways which are less than 3,000 feet, and blue airport icons are between 3,000 and 6,000 feet long. The Vessels tab. Pushing the Vessels tab will display ships or maritime assets in a region defined by the diversion airports entered in the Start Ergo tab. In this example, we're looking at ships between Gander, Newfoundland and Shannon, Ireland. Touching a ship icon will open an information banner. The information displayed from left to right is as follows. The first value is the Z time or universal coordinated time that the vessel reported its last position. It does not reflect when the ship's position is updated. Ships can choose when to update their position. Next is the type of ship followed by the ship's name. If the ship does not report its name, it will show a 9-digit number associated with the ship's identity. Next is the current latitude and longitude fed by received AIS data. This is followed by the track of the ship and the ship's velocity in knots. The last value is the distance of the ship to the aircraft icon. Ships can come in multiple colors. Blue ships indicate the ship position is receiving internet updates. ADS updates ship position every 15 minutes on the hour. To refresh the iPad's ship position, the user must cycle the vessel tab off then on again. Yellow ship icons are ships that have not received a position update in over 24 hours, and red ship icons have not received ship updates in over 24 hours and should not be used since their location is unreliable. Purple ships indicate the internet is lost or is not being received, and the ship position is predicted based on the last update using the track and velocity over time to show where the ship should be. And the predicted position, cycling the vessel tab, will update the latitude and longitude of the ship as well as the ship's position on the app display. This predicted position is very reliable since ships move slowly with little variation in direction. The Config tab. Consider the Config tab as a control panel for miscellaneous displays and an option to improve screen clutter. Under Vessel mode, the user can switch from internet to no internet, feeding this app manually. Switching is fast and display is immediate. Vessel density is a slide bar to manually control the amount of ships displayed. View clusters are available for both ships and airports. With the cluster tab selected, high-density areas of ships or airports are consolidated under an icon with a number. The number represents how many ships or airports are underneath that tab. Zooming in will release and expand the data under that tab. Vessel icon allows the user to select the size icon they would like to display on the Ergo360 app. And finally, the Show Oxygen ETP Flight Plan tab will bring the user to the Oxygen ETP Flight Plan analysis. Finally, the SOS tab. This function is the same as pulling a fire alarm to alert rescue assets and allowing the pilot to resume his efforts to fly the aircraft without distraction. The SOS tab has two functions. The first and most important function is a transmission of a data message that will get transmitted on a dedicated maritime data frequency to all deep water vessels within VHF range. It also sends a text message with pertinent aircraft data such as type of distress, a ditch in this case, time or position, to name a few. This data gets displayed and recorded on the ship's radio receiver screen, which is reviewed by the ship's captain and bridge personnel. The next function of the app is a voice distress message. Once the data message is sent, the pilot will select the ship he intends to ditch alongside of by tapping on the vessel icon and opening up the information banner. A confirmation message will appear, and once OK is selected, it will begin a computer voice-generated distress message that will get broadcast to all ships within VHF range. This message will repeat every 3 minutes with updated iPad information such as latitude, longitude, altitude, airspeed, time to touchdown until the app is closed or the iPad stops working. Should a ship acknowledge the call, the pilot can at any time disconnect the iPad cable from the radio and speak directly to the ship for further coordination. No further action is required by the pilot, and he can return to flying the aircraft. Let's push OK now.
Mayday, mayday, mayday. This is aircraft November 54 Hotel Golf. We are abandoning aircraft in the vicinity of Liberty. Repeat. We are abandoning aircraft in the vicinity of Liberty. Position 41 degrees 2 minutes north, 75 degrees 8 minutes west, at 2151 UTC, requesting passenger and crew rescue. Repeat. Requesting passenger and crew rescue. Persons on board 8. Aircraft altitude. Descending through 10,000 feet 12 minutes to water landing. Over.